It is undeniable that with the rise and advancement of computers, our world has changed at an alarming rate. Take, for instance, the cell phone in your pocket. It connects to other phones and other devices in a vast interconnected system of devices, allowing us to have access to all of humanity's knowledge at our fingertips. Or how the computers that do gigantic calculations help us with new scientific discoveries and new inventions. Computers have advanced so much that a transistor in a computer a couple of years ago, at its smallest, measured about an inch. But now they can be as small as 1 nanometer. To put that into perspective, a normal 8.5 by 11 piece of printer paper is not 1 or 10 nanometers thick, it is 100,000 nanometers thick. But alas, my friends, we're coming up to the end of the age of classical computers, as they cannot get faster or more efficient, and this is where quantum computation comes in. Quantum computation, as its name suggests, utilizes phenomena that govern all subatomic particles in the universe to complete mathematical calculations. But before we dive into how this can change the world, we need to know a thing or two about quantum mechanics. First things first, quantum mechanics is no cakewalk. Quantum mechanics stem from the quantum theory, and each phenomenon, yes, there is more than one, is expressed by incredibly complicated looking equations which probably take too long of a time to solve. Now, I have no idea if the equations on screen are true because I don't have a PhD in applied mathematics, and this is also a picture I got off of Wikipedia. The basic rules we need to talk about are quantum superposition and quantum entanglement. To help us picture these phenomena to avoid complicated nomenclature which we cannot understand, we're going to use ducks and cats. Look at this magnificent mallard and his lovely friend right over there. The first one is called spin up and the other is called spin down. Why do particles have spins? Nobody knows. Both of those ducks are in a state called quantum entanglement. This means that they are connected in some mystical way by some mystical thing we cannot even understand or come to comprehend. However, the neat thing is that as soon as we change the spin, or in this case the orientation of one of our ducks, the other duck will immediately change to the opposite. Interesting, right? This change is instantaneous and can span the entire length of the universe. It is a neat property that can be used to our advantage. The second phenomenon is quantum superposition, which means that in this case a cat can be in two positions at once, and then when tested, it will collapse into one of these two positions. To visualize this, we have a box with a cat inside. Now, what superposition tells us is that the cat in the box can be in two states at once. In this case, it can be either alive or dead at the same time. If we find a dead cat, then the breathing holes on the box are basically useless. Both of these properties can be used to construct qubits, which, unlike normal bits that can either be 1 or 0, qubits can be 1, 0, or both at the same time. Qubits are essentially fake atoms, or in this case fake cats, which are arranged similar to how normal bits are in a computer, logic gates. However, once qubits are tested and come to a value of 1 or 0, another qubit which is entangled with the first qubit changes its state and is measured. This opens up a possibility from our normal plebeian logic gates to quantum logic gates, which will allow us to do way more calculations. If a set of 8 bits has 256 different possible combinations, 8 qubits have a possible 6,561 combinations. Which brings us to how they can change the world. Currently, quantum computers do exist, and you can go mess around with one online. However, these machines are in their infancy, and the most complicated thing done on one is a 2D tank game, which looks like it can be run on my Walmart Casio calculator. However, given time to advance, these computers can change the world drastically. One, encryption will become an irrelevant concept that was once used in the past, since computers will be able to crack codes. This, of course, means that passwords will become obsolete, and things that we rely on heavily, like nuclear launch codes, will have literally no security. Government computers can be hacked and taken over in minutes, if not seconds, and the world could collapse into chaos. but it won't because they'll probably be used for good things, such as simulations. Normal computers can only simulate a limited number of things. They can't account for everything and every possible outcome. For example, molecules. Normal computers can simulate one very, very simple molecule and how each atom interacts in it. Quantum computers have the capabilities of simulating huge chemical reactions involving millions and millions of atoms. And each atom has every proton simulated, every electron simulated, every neutron simulated, everything. This will propel our understanding of chemistry, biochemistry, ushering in a new age of medical developments, gene editing, and disease curing. Quantum computers have the ability to drastically change the world and help with our understanding of the fundamental reality in which we live in.